Alrighty. Welcome, welcome, welcome. So, if you hear my sound repeating a little bit, it's just because I've got a share screen here. But we are going to do this game, the BIDMAS maze, just like we talked about last time, and we didn't get to do it because it was a bit glitchy. Now it should work pretty well. So I'm just streaming or share the screen from my mobile phone. We are going to do this game, the BIDMAS maze. Okay, there we go. Just watching the live feed here. Close this down. Getting the gadgets in order. There's always some gadgets to get in order, isn't there? How it is with gadgets. So let's get into it. All right, let's start. Hopefully we'll get this all going smoothly. Let's give it a minute for a few more to get on the live stream. Okay, welcome, welcome. Okay, welcome. If you're here on the stream, send a message and let us know who you are, where you're watching from. And we're going to get into some maths. And this session is going to be BIDMAS Part 2. So we're still looking at BIDMAS. And we are going to be doing a bit of an introduction to algebra as well, looking at some other aspects of algebra, collecting like terms, and probably get a bit into solving as well. So let's go. Let's see how this works. I'm going to mute myself. So you have to let me know if you're watching. What are we going to do? What do you want to do? These are robots. They're not going to wait. Oh, let's see. Where did we go here? Oh, okay, run away. Okay, so just a reminder here about we have this problem. 17 minus 7 plus 5. And with that, we deal with the minusing and the adding and the subtraction. We deal with that in a linear way, so from left to right. So here, how we'd have to work it through, even though BIDMAS, it's brackets, index, divide, multiply, add, and subtract. Where you have division and multiplication or adding and subtraction, you deal with it from left to right as a group. So we're going to deal with this from left to right because they're equal opposites. So 17 minus 7 is 10. And then we plus 5 to 10, we get 15. Let's just try and get away from these robots. But I don't want to. This one's being guarded heavily. It's like they know. They're guarding the number 15. Okay, let's go down. Okay, I think this one's going to come down. Oh, no, so we're going to go the other way from the top to the 15. There we go. That's all right. Nice. I think that worked out pretty good, don't you? All right, let's try again now. Right, so this one has brackets. And what do we do with brackets in BIDMAS? We deal with the brackets first. B is the first one in the order of operations. So where we see brackets, we want to calculate what is inside the bracket. So we have got 13 plus 2, which gives us 15. And then we've got times 2. So what this is saying is that deal with the brackets, and what the answer is, we have to times it by 2. 15 times 2 is 30, so we're going to go down to the 30. It's unguarded. Oh, there we go, nice. That's pretty good, straightforward. Right, I think it's working a lot smoother on here, isn't it? Okay, so this is 2 times, and we got 3 plus 5. So 3 plus 5 is 8. And then we have to times that by 2. So 8 times 2, 16. No, avoiding those robots. We do not want to get clobbered by them. No way. All right. Now we can see we've got power here. We've got brackets and we've got a power. So we have to be thinking about this one here. So this is 3 plus 7, which is 10. So we do the brackets first. And then after brackets is index, which is 7 squared. Well, if you know times tables, 7 times 7. That power of 2 means it has to times by itself twice, which is going to be 49. So we've got 49 on the right side, and we've got 10 on the left side. 10 times 49, 490. Oh, we're doing all right. Doing them maths games. Right. 7 times 2. Okay, let's run away from these red guys. They're making these dubious noises. Okay, let's just escape for a minute. So 7 times 2, we know that's going to be 14. And then we have 2 times what is within the brackets, which is 14. Okay, they're kind of going to try and close in. Okay, let's get out of this situation. Controls aren't that great on the smartphone. Have to be careful. 28. Let's see if we could finish this game without getting clobbered. Okay, another one on watching on the stream. Good to have you. Let me know where you're at, where you're from. Okay, now where do we go? It says, what does I stand for in BIDMAS? Okay, we're doing this game now. Okay, let's get out of here. Oh, run out, run out. Uh-oh. That was unfortunate. Okay. I was watching the stream and not watching the screen. All right, so I stands for indices. Okay, but this fast red robot is coming here, so we need to get out of the way. Up, down, 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 down. Indices, let's go, let's go, let's go. Oop, the wrong way. Don't go this way, go down. There we go. Yeah, you. That was close. Yeah. Okay, which comes first? Brackets come first, huh? Because B is first in BIDMAS. Okay, this doesn't look good. Gotta get away from this. Oh no, run away, run away. Get out of this situation. That was too close. That was way too close. Way too close. Okay, we have to be careful with these questions. Which of these statements is false? So we have to read them to be sure. Which one is false? Which one's not true? So let's get where we can actually see them. Oh no. Oh no. No way. Ah. Position is key. Getting to where you can see them. Okay, resume, resume. Okay, let's go. Let's go down away from this dangerous, speedy one. Okay, so you can add before multiplying. That is false because you multiply first in BIDMAS. Okay, let's go down, down, down. Down, down, down. Come on, controls. Down, down, down. Okay, this is a race. Away from harm's way. All right, let's look at this one now. Studying the question, we can see which is higher in the order of operation is powers. And we've got 3 squared. 3 times 3 is 9. I'm going to get rid of portal there. All right, and then we've got times 2. So we've got 3 times 3, which is 9, times 2, 18. 2 times 9 is 18. We got 1 heart left. Not for lack of correct answers, but these robots are getting tricky. Okay. So 7 plus 5. Oh no. Run away. Okay, I'm just going to focus on running away. Oh, there's 3 of them chasing me in one go. That is not nice. Leave me alone. Look how good they are on the chase. They're not playing around. I'm just trying to escape here. Yeah. Okay. Through the portal. Oh no, but he see me. Okay, run away. The controls. The controls. Oh no. Oh dear. Oh dear. Controls aren't as good on the mobile phone, but we had a good crack at it. Hopefully, it's refreshed your memory on some points of BIDMAS. Okay. Now, I'm going to come out of this one here and paste another link in. Paste, and go. And it's a similar maze kind of deal. And we are going to look at, let's open this here, that's fine. We are going to look at collecting or combining like terms. And before we do the game, let me come here and just, there we go. You can probably see it. So I'm going to annotate on the screen using my finger. Oh, yes. And color red, that's good. That stands out a bit. So collecting like terms means that terms represent ideas. I may have B. So if I have, say, 5B, maybe those Bs are bananas. And what that represents is 1 banana, 2, 3, 4, 5. But I'm representing it as 5B. Okay, so this B is a term that represents ideas of bananas in this concept. So if maybe each banana cost 40 pence and I've got 5B, I know I have to do 5 times 40. Okay, which is going to give me 200. And if it's in pence, that's 200 pence, which means it will cost £2. Can we move this display? Okay, £2 for those 5 bananas. And this is representing concepts in what we call algebraic terms, and we use letters for that. We use any letter of the alphabet, from A to Z, any letter. And even sometimes we can have letter groups of letters. It sounds completely bonkers, but it's true. We can do that. If we're going to have groups of apples and bananas, or maybe A amounts of B. So say if I had 1 apple and I had 1 banana, then I could represent that as A, B. And what I'm saying is they're in the same group, they're in the same bowl, if you will. Another thing to know about terms, and when you have numbers next to them, just like with the 5B, okay, or 5 bananas. Okay, let's draw them again. 1, 2, 3, 4, 5. Should really use yellow because yellow's, bananas and everything. What this really means is that I have 5 amounts of whatever B is. So if B is bananas, I can also say it's 5 times B. Okay. So even though we don't tend to see the times there when we're dealing with algebra, imagine in your mind that there's an invisible time symbol that is between your number and your letter term. And that's how we deal with algebra and expressions. Okay. I'm going to clear this again and look at an expression. So if we had, for example, 5b plus 4 equals 24. All right. This is where our BIDMAS practice starts to come into play. because we know BIDMAS is brackets, indices, divide, multiply, add, subtract. And if we look at the order, we know now that 5b is 5 times b. So we know we've got a times in there. Plus, so we've got an add in there. 4 equals 24. But in order to get to solving, well, then what is b worth as a number? We have to reverse BIDMAS. So I'm just going to change color here. Excuse me. We have to go the other way. So we deal with order of operations to know how it operates from the most important factors to the least most important factors in calculation according to the order. But when we are solving, we do it in reverse. We go backwards. We have to reorder it based on the smallest and then work our way up to what is the biggest, most powerful function of the operations that we use. So let's take away 4. And why we take away, is imagine it's on a scale. You know those old-fashioned scales, those old-fashioned weighing scales? Then this equal sign is like the middle of the scale. You know those old-fashioned ones where you have these fulcrums here and you have the bowls on either side. The equal sign wants to keep things balanced. So whatever we do on one side of the scale, we have to do on the other side of the scale. Otherwise, it will unbalance itself and tip. So if we're going to take away 4 from this side of the scale, we have to take away 4 from the other side of the scale. So then 24 minus 4 is 20. So we can just overwrite that as 20. I've dealt with the 4 because I've taken away from it. But now I've got 5 amounts of b. Now this is 5 times b equals 20. So to reverse that process, just like I reversed a +4 with a -4, and I did it on the other side, I have to now divide by 5 to reverse this. Okay, so when I divide by 5, I get rid of the 5 amounts of b and just left with 1 amount of b. But I have to do the same with 20. So let clear screen, and of course 20 divided by 5 equals 4. So in that calculation, b is equal to 4. Okay, that's a little touch on solving. Now, with collecting like terms, terms which are the same, we have to group together. And that's called simplifying as well. You saw me working with the 5b. 5b is essentially b plus b plus b plus b plus b. And that equals 5b, or 5 amounts of b. So we're collecting them and we're grouping them. So all of this idea of the 5 amounts of b is simplified in just 5b, aka 5 times b, aka this 5b means I've got 5 of whatever b is. And in algebra, terms stand in place of numbers. So we can deal with unknown ideas numerically and work out their value. So I'm going to undo that as well. So say if I had b plus b plus b plus 2b, if I group that, it's going to be 5b. Okay, still 5b. It's meant to be a b, not a 6 looking thing. Because this is 1, 2, 3, and this is already grouped as 2 of what b is. So I've got 2b plus 1, 2, 3, 2 plus 3, 5. So I've got 5 amounts of b. And this is collecting like terms. Okay, so I'm going to clear this screen here, remove this box out of the way. And there we go. We're going to have a go at this game. Okay. and we're going to deal with collecting like terms. And then afterwards, we're going to jump into just a bit of a recap of BIDMAS, dealing with some brackets and more complicated stuff to a degree. And then we're going to move into more algebra functions and solving and how we deal with that. All right, here we go. We're going back into the maze. Hopefully the controls will be a bit easier this time. We'll see. All right. Okay, so this is starting on the upper end, isn't it? Looks like, definitely. You may look at this and be like, what does this even mean? But we can see the y's here. Let me just hide in a corner somewhere, as you do when you're being chased by angry robots. So we've got 9 amounts of y cubed. We've got 5 amounts of y. And we've got minus 2y squared plus 8. Now, the thing about this is even though these terms are all types of y, we can't take away a power amount of a group of y unless it's taken away from the same type of power. If it's not, then literally we can't really change it. It has to stay exactly the same as it is. Okay, so it's the same answer. If there was another y cubed, we could take away from that. If there was another y squared, we could take away from that or add to it. If there was another y, just a number of y, we could then collect that together. But because they're all different and then the number isn't got anything really to do with y, we can't simplify it. All right, let's look at this. So this is 5z plus z. I think you'll know what we'll have to do. We've got 5 amounts of z, and then we've got another z, which we're adding to it. So we're going to have 6 amounts of z. So let's go up to 6z and not get knocked badly by this green robot here. There we go, 6 amounts of z. Nice. Okay. 7y minus 3y. Okay, so these are all the same terms of y. None of them is a power. So looking at this, we can almost treat it like just 7 minus 3, but on terms of y, which isn't going to be 4 because the y is still there. Some make the mistake and think, oh, 7y minus 3y, that's going to be 4 because 7 minus 3 is 4. We're forgetting they're amounts of y, they're groups of y. So it's going to be 4y or 4 groups of y, whatever that number is or that concept, that's what the answer is going to be. So let's go to 4y. Making a good escape here. This making sense? Give me a thumbs up in the chat, let me know. Okay. All right, we got 4a plus 9a. Okay, let's run away from this guy. That was really close. Uh-oh. Okay, ended up in the right place. That's you know. That was handy. Sometimes you're just going to run and hope for the best, you know? Right, 3y plus 7y. We can tell what's going to happen. This is going to be 10y because 3 plus 7 is 10. Got to watch this red guy because they're fast. All right. There we go. Okay, no, wrong way, wrong way. Go this way. Come on, robots. There we go. Like I said, controls aren't the greatest on a mobile. Okay, 4x plus 9 plus 2x. So we've got 2 terms of x going on. And to simplify them, we want to group them together. So we've got 4 amounts of x plus, let's run away from here, 2 amounts of x, which will give us 6 amounts of x. And then we've got plus 9. And that's a number. So that's not affected by the terms. We can't collect numbers and terms together because they represent different ideas, okay? Ah, we're doing all right. I think we're doing all right. Okay, got a power now. Okay, we got 6y squared. And we've got, okay, run away. That was so close. Run away. Okay, okay, can't get back in that way. Okay, run away, run away. This guy is on the hunt. They are not playing around. Okay, that's I don't think they can go through the portal, so there we go. Good escape. 6 plus 3, 9, and the amounts of y squared. So we had to get there. Excuse me. 8x minus 2x, or 8 minus 2, 6. And they're both terms of x exactly the same way. So we need 6x. That's okay, we're gonna make this, good. Ready. Okay, another big one. Looking at this, we can see we've got powers of x squared, and we've got x terms with no powers, and there's 2 of them each. So what we want to do to collect them is we deal with the powers and the no powers with the no powers. I just want to keep running around in circles away from this guy. Okay, so we've got 10x squared minus 3x squared. 10 minus 3, 7. Well, wrong way. Oh, controls. And then we've got an x, the 7x minus 5, which is 2. So you've got 7x squared plus 2x. And that's the answer. Right, so here's a walkie-talkie through this one, isn't it? All right, let's talk through it. This looks a bit precarious. Okay, run away. Again. Oh, alarm. Apologies. Lots of techie stuff going on here, isn't it? So 2x plus 3x is 5x minus 5x. So this is 5x minus 5x. That's going to be 0 because the same thing can cancel out the same thing. Just like if you have 2 minus 2, it's 0. You've got a certain amount of x minus the same amount of x, cancels out, becomes 0. So we can negate things. There we go. Nice. We have completed. Hooray, hooray. All right. There we go. That's good. All right, just going to get this one out here. Fantastic. Cool. So let's get into some more algebra now with a little bit of a recap on BIDMAS. Okay. And this time we're going to look at some powers and things like we talked about and process through some of these systems of learning. All right, I'm just going to share screen. Give me a second here to get my ducks in a row. Robo ducks, as it were. Share. Sharing with sound. And this says, who is correct? What do you think? Who is correct? Well, I'm going to click on to find out. So we got 5 plus 2 times 4. Okay, Tracy says the answer is 13. Tyrone says it is 28. Explain how they got their answers and who is correct. So have a look at that. Who do you think is correct? How they get the answers? Have a go, work it out. Okay, let's, there you go. Okay, who do you think's correct? Okay, let me get my graphics pen and do some annotations. We've got to figure this thing out, don't we? Let's figure. Let's use our skills, use our knowledge, use our practice, draw upon previous understanding and apply it to our present situation. That's what we're going to do. That's how we solve things. Okay. So let me get my annotation. There we go. And here we go. So knowing our BIDMAS, just write out BIDMAS. We know we want to deal with multiplication first in priority because we see we've got a multiplication and we've got an addition. So we want to do it in this order of priority. So we're going to do 2 times 4 first, which gives us 8. Now we can rewrite this then, because this essentially means the same as 8. We can say 5 plus 8. Okay. And then we're going to get 13. Okay. Because if we do our partition, if we want, with 5 and 3, which makes 8, we know 5 and 5 is 10, and a 3, 13. So we know Tracy got the answer right. Tyrone got it wrong in this case, but how did he do it? Well, he probably followed it on the same linear sense and treated adding and multiplication as if they have the same strength, if you will, the same potency, as if they operate on the same terms. And they don't operate on the same terms. The only ones that operate on the same terms in a linear sense is division and multiplication and addition and subtraction, because they're direct opposites of each other. But if we're going to deal with one from, say, the division multiplication group and another from the addition subtraction group, we can't treat them as if they operate the same way on the same level, because they don't. So they must have done 5 plus 2, which gives you 7, and then times that by 4, which then gives 28. Okay, so they dealt with it in the wrong order of operation. Right, let's move on. Okay. Okay. There we go. There we go. Doctor, you have so many surgeries to perform. Where are you going to start? Simple. I use an order of operations. Ah. Well, that was a little bit punny, wasn't it? A little bit punny. Oh dear. All right, let's move on. So, BIDMAS, order is important. As a quick reminder, brackets, indices, division, multiplication, addition, subtraction. Okay. Are you sure I make a difference? Are you sure? Are you sure? That's a funny one, because a subtraction does make a difference, doesn't it? That's a good way to deal with minusing, is if we can know the difference, because it gives the same thing. Like if I have 8 and I have -3, it gives me 5, because the difference between 8 and 3 is 5. 3, 4, 5, 6, 7, 8. I've done 1, 2, 3, 4, 5 jumps to take me to 8. So that's the difference. That's how subtraction works. I'm positive. Of course, the plus would say that. The plus is always positive, aren't they? Yes, always positive. But the minus can be a bit negative sometimes. Okay. Here's something to remember. When dealing with algebra, keep it positive when solving. We'll get to that when we deal with solving. So when dealing with algebra, keep it positive. Okay, when solving algebra, keep it positive. I can say it a different way. When solving equations, keep it positive. I'm saying this a few times just to drill it into the understanding, just to have that repetition. It's really important for you to do that. It's really useful, and we will find out why soon enough. Right. So multiply, divide before adding or subtraction. We're going to try these. Going to have a go. Okay, so if you're here, have a go. Work it through. Give it a few seconds on the clock to work through these. Okay, and then we'll look at the answers. Right. Quick note. Multiplication and division have equal status, which means if they're on the same type of equation that you're looking at, you could deal with them in a linear sense. Okay, something to note. All right, have a go at these. Have a go. Just going to give a bit of some time on the clock. Okay, I'm going to give, well, that's 5 questions. I'm going to give maybe 1 minute and 30 seconds on the timer. And have a go. 1 minute and 30 seconds on the clock. I'm going to start maybe some nice timer music. Okay, so it's good to have some timer music. Helps the ambience. Helps the atmosphere a bit. There we go. Right. Yes. Okay. Yeah, that's cool. That's a good one. Yeah. All right. Okay, timer music. Okay, we have time. How do we do it? What's the answers? Let's go. So, moving on, these are the answers. Remembering our order of operations and how we deal with it. What is on the same level is timesing and division, and is addition and subtraction. So in the same problem, we have to deal with the multiplication first. Okay, so 2 times 4 is 8, and then we add 6, 14. It's 8 plus 6, 14. Okay, 8 divided by 2, 4. And then we're going to take 4 from 12, 8, etc., etc., etc. Okay, skipping along a bit. Like I said, this was just a refresher on your BIDMAS stuff. Okay, all right, nice. Gotta admit, that's a little bit funny there. What tools are using maths? Multipliers. This is A-class joke material for you to take into your next maths class. You know. All right, rule number 2, brackets are always first. Okay. There's a good one here. So how could you change the sum to make Tyrone's answer correct? Because brackets can force an operation, because you have to deal with what's in the brackets first. How can we adjust it? How can we change it so that even Tyrone would be correct? We could put a brackets around the 5 plus 2. And then Tyrone is right. I know. Wild, isn't it? But that's what brackets can do. It collects together whatever process you're dealing with, and you have to deal with what's in the brackets first. So outside with no brackets, well, yes, of course, the other one was right. But with brackets put in this location here, then Tyrone is correct, because we have to do 5 plus 2, and then we times it by 4. Okay. All right. Okay. Got another few to work out here. Let's work these out using brackets and force change how we deal with it. And look at this one here. This is interesting, isn't it? Because it's right in the middle. It's right in the middle, isn't it? Fascinating. So how do we do that one? Have a think. Okay, I'm going to play another music timer for us to have a go at these. All right. There we go. There we go. Right. There we go. Right, so some time on the clock. Starting. Seconds left. Alrighty, that is time. What are the solutions? Okay, all right. Hopefully you had some time, you got that, or got some of them. That would be great. And that would be great to go through the process to practice those methods. So 6 plus 2, 8 times 4, 32. So we can see how in each of these we have to collect together and calculate what is inside the brackets. And that's how it has to work. Okay, let's look at this one here. Excuse me, at the bottom here. So number 5, we can see we've got 5 times, open brackets, 4 plus 12, which is 16. And then we've got divided by 4. So this is saying then, if we have 16, we divide it by 4, okay? And then we times our answer by 5, we get 20. Because 16 divided by 4 is 4, times 5, 20. Okay? Now you're thinking, wait a minute, they're on the same strength, right? So shouldn't it be a case that we're doing 5 times 16 and dividing our answer by 4? Well, let's have a look at that. Okay, there we go. So it's the same answer. So even if we do 5, and we're going to times 16 by 5, 6 times 5, 30, carry the 3, 5 times 1, 5, 6, 7, 8. And then we're going to divide that by 4, 80 divided by 4. Well, look, 8 divided by 4 is 2, and then we have to carry the 0, 20. Same answer. So whether we deal with it, oh, sneeze, pardon me. Excuse me. So whether we deal with it from in a linear sense from left to right, or we deal with this order in BIDMAS and we treat it that way, it's going to give us the same answer, especially with multiplication and division. So it's going to give us the same answer. So that's really useful to know. But we can deal with this one first because, well, it's initially a simpler calculation. And if these are the same weight and the same strength and the same opposite processes, then you could more quickly solve it if you can spot at a glance a more direct calculation that you can work with first and then simply calculate it to get the same. Okay. So look for what you can use, especially when they're on the same level and the same strength. Okay. I was trying to stop laughing at all the good bracket strokes, but I couldn't contain myself because brackets contain. There we go. Oh dear. All right, quick recap. Okay. Indices. Oops. Okay, I think solutions here. And here's the thing. Anything to the power of 0 is 1. Okay, that's that's just a general rule. You could have any number to the power of 0 is 1. Powers are quite interesting because I think I mentioned this before. We can have powers of fractions as well, powers of negatives. We can have a look at that when we get into more complicated specifics of dealing with index laws or the power laws. Okay, how to handle that. All right, quick here. Okay. So indices are evaluated after anything in a bracket, okay, but before any of the 4 operations, okay? So we're not going to do 2 times 4 and then try to power everything up. We're not going to do that. We're going to do the 2 cubed first, which gives us 8, and then we'll write it out. And then we'll handle the next order, which is 8 times 4, 32, and then we'll add 5 to that as well, giving us 37. Okay, let's clear this. Okay. Interesting. How does this change things? Something to think about. How does this change things? Remembering what we know. Okay. This now means we have to contain what the answer is inside the brackets first. Okay. So 2 cubed gives us 8. And then we have to add 5 to 8, giving us 13. And then we times that by 4. So we're going to get a different answer, aren't we? Okay, 52. Right. I'm going to take a screenshot of this here. And I'm going to see about posting this screenshot on the group for you to try out these questions. And then we're going to skip on through, just because of time, onto our next point of business here. Okay. Right. All right, so you could pick which one you think that you want to practice with. All right, so we have the mouse level, the cat level, or the elephant level. Okay, so you could choose which one you want to tackle with, huh? So the mouse level is a lot more, straightforward, a bit simpler. You can work your way up. You can say, okay, I'm gonna progress through. That's fine too. Or if you want to just zone into the middle zone, where it's a bit of a medium difficulty, that's okay. Want to go for the standard difficulty, that's fine. But if you want to go for something more weighty, a bit more advanced, a bit more challenge, then pick the elephant, go for the elephant. All right. And then we'll look at the answers and move on to our next topic we're going to introduce. All right. So have a go. Have a go. And you know what that means? It's another music timer on the clock. So whether you picked red, amber, or green, the mouse, the cat, or the elephant, same time on the clock, maybe a bit more this time, maybe about 2 minutes. See how many, and let's go. Okay. All right, that is time. And now for the reveal. Okay, 5 minus 16. If you got these, excellent job, well done. 25, 1 for speciality. And then we've got 48, 20, 0 for that one. Because like I said, sometimes if you get the same after collecting everything together, you can cancel it out. 9, 225. 5, 86, and 2. Great job, everyone. Well done, you. Right. We're going to look into our next order of business, which is equations. Okay. And solving equations, let me close some stuff down here. Give me a sec. There we go. There we go. There we go. Right, there's a few key words we want to look at and a few ideas that we want to understand. We're going to revisit a few things when it comes to collecting like terms, because in order to solve, we're going to want to collect, because if we don't collect things together, what happens is we end up with all of these different symbols and terms and ideas just spread all over the place. And it becomes overcomplicated, it becomes too cluttered, it gets a bit messy. And then if it's not organized, it's really hard to have the right solution. So we want to make sure that we organize things in the right way, which is why we want to collect like terms as a practice and as a habit when dealing with these things, so they don't get disorganized and we're not having to just work too hard. We want to work much smarter than harder. And if we leverage working smarter and working better, quality over quantity, so to speak, then we're going to get more done with least amount of energy drain, put it that way. So we want to work a lot smarter. Collecting like terms with dealing with algebra helps you do that. And the reason why we start with the algebra focus like this is because in IGCSE maths, algebra is spread across so many different topics. Almost every topic has algebra in it to some extent. Your word problems will have algebra. Formations will have algebra. Your shapes in geometry will have algebra. Circle theorem will have algebra. Angles will have algebra. The list goes on. The list goes on. Vectors have algebra. It's such a prevalent topic. The more practice we get dealing with it, the easier those other ideas will be when we start to get into them. Okay. Let me share. We haven't got too much time, but like I said, just introducing solving equations here. Right, so we're in the zone. We want to match some of these keywords with their definition. So we've got formula, equation, expression, identity equation, linear equation, term. We've talked about term. We've dealt with that. We've covered that. We should know. Okay, let's have a look. So formula. This has multiple unknowns. We use it to solve problems. For example, we can find the area of a circle using A equals pi r squared. So A meaning area is equal to pi, that pi theorem, the pi symbol, times r. So knowing what we do with terms, when we have a term next to a term, it's a term amount of terms, or they're timesing by each other. So we have pi times r squared, and r in this case is the radius. So we can work out the area of a circle with this formula. It's a formula for circles. There's formulas for many different things. There's formulas for circles, there's formulas for parallelograms, there's formulas for trapeziums, there's formulas for working out the area of a square, of a triangle, of rectangles, of all these different types of ideas. We could come up with formulas to handle how to calculate specific parts of whatever thing that we're dealing with. And that's what formulas are there for. Equation. This has an equal sign and solutions. Okay, plural, can be two solutions when we're dealing with quadratics. Not talking about that just yet. We'll go further down the line and deal with that when we cross that bridge. So for the unknowns, for example, 3x equals 12. So it has a solution of x equals 4. So just like we talked about when I did the whole annotating on the screen thing with my finger with the bananas, this means that we can reverse what this represents using our BIDMAS knowledge. So 3x is 3 times x, or 3 amounts of x. And what that's saying is, whatever x is, I've got 3 of them. And when I have 3 of them, it gives me a number 12. So then if we divide 3 on both sides, because equals means this is the same as that, 3x as an idea is the same as 12, we have to handle them with the same process to actually get to the bottom of this. So if we divide 12 by 3 and divide the other side by 3, then the 3 goes away, we're just left with x, and the 12 calculates down to 4. So then we have x is the same as 4. Okay, we can get to the solution and solve unknown ideas, unknown problems using equations. Okay, expression. Mathematical phrase containing both letters and numbers, but never an equal sign. Okay. So if we had 3x, that's an expression, but it becomes an equation if we say 3x equals 12 or equals something, then it's an equation. Then we can solve it. But an expression carries the idea of the term and the number, but isn't equal to anything necessarily yet. When we're forming equations, we're dealing with different expressions and we are organizing them together to turn them into an equation so we can begin to solve problems. More on that as we go on. Identity equation, linear equation. So this has a solution and the powers of the variable are no greater than 1. For example, 3x plus 1 equals 13. Okay, moving on because of time. Density equation. This is true no matter what values are used. For example, a plus b is equal to b plus a. Now, it's the same. But whatever you swap them around, it's the same. Just like if we were to make them as numbers, say imagine a is 3 and b is 7. 3 plus 7 is 10. Just in the same way, 7 plus 3 is 10. Okay, so this carries the idea that it always has to be true. Okay. All right, last one is a term, a collection of numbers and letters, but not plus or minus. For example, x or 3y or 2a squared. That's a term. Okay, cool. Right, that is time for now. Next, we're going to get more into the direct practice of solving equations, where we're going to revisit all of these different aspects that we looked at, from formulas, equations, terms, identifying them and using them to handle number-based problems, shape-based problems, word-based problems, and even picture-based problems. We can use that and do lots of solving, getting to the bottom of our algebra. Great. Hope you had a nice time. Hope you enjoyed. I started with games just like I said I would, with the maths mazes. And I'll see you next time at the Mathsphere, where we are going deeper